Hey programmers, Alvin here. Right now I want to go over a Python code solution for this intersection problem. So hopefully you made some sense of the approach video, because we're just going to implement that to the T. So let's start with maybe a really simple brute force. So let's say for this intersection function, we know we want to generate a list containing our overlap, so our common element result. So I'm going to start that off as an empty list, but by the end of my function, I'm going to of course return that result. If you want like a nothing fancy solution, I would just iterate over every element of my first array, or my first list rather, so A. So I can say maybe for item in A. So just iterating through the items of that first list. And for that item, I could, if I wanted to, like nest another loop to iterate through the elements of B and just check if the item from A is the same as the item from B. Or I could just use a built-in function. I can check maybe if this item is also in B. So maybe you're unfamiliar with this syntax, but you can just quickly, at least in the code style, you can quickly check if an element is in a list by just using the in operator in Python. If you use it in an if statement, it just tells you true or false is that item contained. So if that item's in B, then I can just do result.append that item, right? Because I already know that for sure, item is definitely an A. That's how I'm iterating through it in the first place. And only in addition to that, should I check if the item is also in B. So that should just check for the common elements. And just because I think it's important that we slowly step through some of these core patterns, especially if it's the first time I use them. If I had some, I don't know, list, I'll say my list equals some elements, so 1, 5, 3, 2. And I can print out, I'll say, is 5 in my list. That should give me a Boolean. I can also check is 42 in my list. So let me just run this as a script. So you just see these prints. And I should get true and false respectively over here. Cool, and there I see it. And now it's no mystery how I'm using that expression inside of this if statement. So it's really cool in Python, right? The in keyword has different meaning and different functionality depending in the context you use it, right? So I have like a for in or I have an if in, do different things. But that being said, let's go ahead and run the test for this. And unfortunately, I do believe that the in operator just does like a linear scan for the element. So technically, like under the hood, doing this expression would really cost us like an O of n runtime, right? Technically, this is probably just iterating through every element of B and checking if the item's inside. And there I see that, right? Looks like I time out for the fourth example. If I take a closer look, that fourth example gives us a really large input. It looks like it just gives us A and B such that the elements are from 0 to 50,000. So that's 50,000 elements, right? You can already see that if I say that like N is the length of the A list and then M is the length of the B list, technically this kind of translates to nested loops. So it would give us a runtime of O of N times M, which is going to be too slow to pass these test cases. And so if you want to do the optimal solution for this, you'll have to use a hash data structure to check for membership. So in Python, for us, we can do that easily with the built-in set. So what I would do is perhaps create a set. So I'll say, I don't know, my items starts as an empty set. So I'll show you a few ways to implement this. So I can create an empty set like so. And for kind of phase 1 of the algorithm, I'm just going to take the elements from list A and just add them into this set. So I'm a little rusty in my Python, but I think it's just items.add, I can say. I'm going to add this item to the set. And let's just take a look at how that maybe prints out. So I'll print out the items. So just a quick little debug for me. I can just run these test cases manually because it might be your first time dealing with Python sets, in which case it's all good. We'll kind of warm up together over here. So let's run this. Cool, so notice that it does print out the set. So just basically converting all of the items of list A into a set. And a few properties of sets you'd like to know. The lookup time for a set is O of 1. So inserting elements O of 1, checking for an element O of 1, and also set items are going to be necessarily unique. So you can't have duplicates in a typical set. Cool. And so from there, now I just need to iterate separately. So it's really important that I don't nest this next for loop. I can maybe iterate through the items of B. Maybe I'll use a different variable name here. So I'll say for, let's say, Ellie in B. And I'll check if that element is inside of the items set. So now items is a set. I can check if Ellie in items, and maybe it would help if I was a little more distinct here. I'm going to rename items to items set. Cool. So if the element from B is in item set, then that can contribute to my result. So I can do result.append the element. And I just want to return the result at the very end. I'll remove some of that debug code. All right, so this code looks pretty good. Let's go ahead and just run the test cases on it. So you'll notice that I'm using the in operator once again in Python. And again, it's context sensitive. So technically the in operator works on all of your collection types in Python being your lists, your tuples, your strings, your dictionaries, your sets. And in either scenario, when you use it inside of a conditional, like an if statement, it's just going to tell you true or false is that element inside of that collection. So is that Ellie inside of the set? And depending on what structure you're using, what collection you're using, it could have a different runtime. And so what I'm counting on is if I check for membership in a set, this expression should now only cost a constant time for lookup, so O of 1. So my hope is when I run this, I should be able to actually pass all of the test cases now. Cool, and we see a very tangible difference. We're able to pass that test case where before we failed it due to a timeout. So maybe I'll show you a few other ways you can express this pattern. Python is one of my most favorite languages for this reason. It's very expressive, something that you should kind of adopt if you're kind of choosing Python as your language of choice. Use the facilities of the language, right? So I can do things like comprehensions. So if I want to quickly refactor this code, to maybe quickly turn my first list into a set, I believe you can just pass in the elements A like this. So let's try that code. We'll give it a go. So I don't need to actually explicitly loop over it. I believe this will work all the same. So, right, so even cleaner, right? Just immediately checking and converting a list into a set. So if I pass in a list into like, we'll say like the set constructor, I'll just convert it for you. So pretty clean. And what we can also do is maybe just a comprehension to get our final return value. So this is, to me, very Pythonic code. So I can just do this all in line. I can just maybe return a new list, right? So I'm using brackets, and I can comprehend on the inside. So I can say maybe for, I don't know, Ellie in B. So technically this just iterates through the elements of my B list. And I want to only take that element if the elements in the item set. Cool. So technically this is looping, and it's going to generate and comprehend a nice list for me. So I'll run that. Pass is all the same. Quite a fan of this code. If you're unfamiliar with Python syntax, I think, if you're going to be a Python programmer, you should learn to adopt this syntax. It's very commonplace in Python. But for now, if you find this a little jarring, then just go ahead and do the more classic solution where we kind of create the empty list up front and just append elements to it over time. But with that, make sure you understand why we choose a set here, right? It's a hash data structure, so it gives us O of 1 lookup, giving us a very fast solution, right? Now we have a linear runtime.